When you hear the words special relativity, what comes to mind? For a lot of us, it's baffling equations and paradoxes that honestly just make your head spin. It's been puzzling people for over a century. It's the kind of stuff that can make you feel like you're just not smart enough to get it. But what if the problem isn't the physics? What if the real problem is just the language we use to talk about it? Now that's an interesting idea, and it's exactly what we're diving into today.
Okay, let's start with the classic mindbender, right? You've heard this one. Does a speeding spaceship really shrink? I mean, if a rocket zips past you super close to the speed of light, does it actually physically get shorter? It feels wrong, doesn't it? But weirdly enough, this is a cornerstone of the whole theory.
And it doesn't stop there. What about time? Do the clocks on that same spaceship, do they actually run slow? I mean, literally tick-tock slower than the watch on your wrist? Does time itself warp for the people on board? And look, these aren't just fun what-if questions for science fiction. People have been seriously debating this for decades.
So into all this confusion steps our guide for today, William A. Shurcliff. He was a Harvard physicist, and he basically looked at all the head-scratching around relativity and said, okay, enough is enough. Just listen to his confidence here. Many textbooks say yes, a few say no, some hedge. Here we give the correct answers briefly and convincingly. I mean, wow. His goal wasn't to rewrite the physics, that was solid. His mission was to fix the language, to give us a clear path through what he saw as a fog of confusing words.
So what was his grand plan? Well, he built a whole new toolkit. And we're not talking about wrenches and screwdrivers here, but a new set of words, a whole new language designed to make sense of this new reality.
You see, Shurcliff's biggest beef was with the standard physics books. He thought they were just, well, to use his words, wordy and foggy. He felt that everyone was trying to cram these huge revolutionary ideas into old, clunky language that just wasn't up to the task. It was like they were relying on shaky metaphors, when what they really needed were sharp, precise tools for the job.
And this right here is his master key. It's a term he invented called EFO reality. Now, EFO is an acronym, and it stands for something so simple but so powerful. Effective with respect to the indicated frame only. Think about that. An EFO property isn't some absolute universal truth. It's just a measurement that's true only from your specific point of view, your reference frame.
Okay, that might sound a little abstract, but Shurcliff had a great way of explaining it. Let's take a football field. What he calls its broad reality, its true, undeniable length, is 100 yards, right? Anyone standing on the ground will measure it and agree. It's just 100 yards long. But for that spaceship we talked about, the one speeding past at 87% the speed of light, its measurement of that same field comes out to just 50 yards. Now, here's the crucial part. The field didn't actually shrink. That 50-yard measurement is an EFO length. It's a reality that's only true for the spaceship's point of view.
And he didn't just stop with EFO reality. He looked at other words he thought were clunky, like simultaneous. Why use a long word like that? He just invented cotimey. It means at the same time. Simple. And its opposite, distimey, not at the same time. He did the same for location. Co-placey for things at the same place, and displacey for things, well, not at the same place. And look, this isn't just him playing with words for fun. It's about building a language that makes the incredibly weird rules of space-time actually feel kind of intuitive.
Okay, so it's important to remember Shurcliff's new language isn't some kind of magic trick that changes physics. Nope. It's just a much, much clearer lens for looking at the fundamental, unbreakable rules of space-time. His whole system just helps us see the laws that were always there, but in a way that makes all those old paradoxes just melt away.
And for Shurcliff, it all boils down to just six basic laws. He argued that if you can just wrap your head around these 6 principles and really truly accept them, no matter how much they mess with your common sense, then everything else, all the bizarre, wonderful stuff about relativity, just follows. It all clicks into place, simply and logically.
And this is law number 2, and it's the big one. It's the most foundational and honestly the weirdest rule of them all. It says the speed of light is constant, always, for everyone. It doesn't matter if you're flying towards a flashlight at 1 billion miles an hour or running away from it. If you measure the speed of its light, you get the exact same number every single time. It's an absolute cosmic speed limit, and it just completely shatters everything our intuition tells us about how speed should work.
So what happens when you have a rule that weird? Well, you get some crazy consequences. And this is law number 5, the relativity of simultaneity. Using Shurcliff's awesome new words, it means that two things you see as co-timey, happening at the exact same time, someone else flying past you will see as distimey. They'll see one happen before the other. This just completely blows up the whole idea of a single universal now for everybody. It doesn't exist.
All right, so we've got our new toolkit, we've got the unbreakable rules of the road. Now, it is time for the payoff. Let's take this system for a spin and see how it completely solves those questions we started with.
So, let's go all the way back to the beginning. That spaceship, does it really shrink? I think we've all been waiting for this. Using Shurcliff's clear language, can we finally get a straight answer? Does it actually, for real, contract?
And here it is. Thanks to Shurcliff, the answer is a simple, confident no. It does not really shrink. Its broadly real length, the length the people on board would measure with a tape measure, is exactly the same as it always was. That shorter length that you see from the ground, that's its EFUF length. It's a real measurement, but it's a reality that's only true for you, in your frame of reference. So you see, the weirdness isn't in the spaceship. The weirdness is in the very act of measuring things across space and time.
And for Shurcliff, this was about so much more than just getting the right answer in a physics textbook. It was bigger than that. He saw it as a kind of philosophical awakening. As he put it, special relativity gives man his first clear view beyond the limits that have been accepted since time immemorial. It's like, by finally getting the language right, we can see a deeper reality, one that's been hiding behind our own common sense this whole time.
Which, of course, leaves us with one last big, lingering question to chew on. Shurcliff proved that things we thought were totally solid and absolute, like length or what now even means, are actually relative. They're ephemeral realities. So it really makes you wonder, right? If our measurements of time and space are this flexible, what else in our lives, what other things that we assume are broadly real and true for everyone, might just be a matter of our own personal point of view?